Hi students, in this video we are going to start the new chapter in the 10th standard about the number 3 chapter, metals and non-metals. Yes, metals and non-metals is the title of this chapter. In your day-to-day life, you are using many substances. It may be an metal or non-metal. For few of the substances, we can decide it whether it is a metal or non-metal by observing its physical property. By observing its physical property. Means by looking at it, we can say whether it is a metal or non-metal. So some of the physical properties, we are giving some introduction for them, which we had already learned in the previous classes, but just to recall. So let us see what are the physical properties that are going to decide whether a substance is a metal or non-metal. Let us see the first physical property, that is called metallic luster. What is this one? Metallic luster. If I take a chalk piece, is it having any shiny nature? No, it does not have any shiny nature. But if you see the gold ornaments, they will be having shiny nature at their surface. Shiny nature at their surface. So the property of a substance to have shiny surface. The property of a substance to have shiny surface. It is called as the metallic luster. Most of the metals will be having this metallic luster in their pure form. In their pure form. Yes, this point you must not forget. When they are in their pure form, only they will have the metallic luster. We have learned when iron is in its pure form, it will have some lusters in nature. But when it is reacted with atmospheric moisture, then that will change into the rust, which will not have any metallic luster. Means it is now in its impure state. Even the copper, that is having a brown color luster, when it is exposed for carbonate, it develops a green coating over its surface, which decreases its luster. In the impure state, their luster decreases. Or the silver articles that are shiny, when they are exposed for sulfide, they become black in color. In their impure state, they are lost in their shiny nature. So when do we say a metal will be lustrous means when the metal is in its pure form, then only the metal will be showing its lustrous nature. So that is only due to the surface phenomena. It is due to the surface phenomena or the surface shining of the substance. Okay, let's continue about the second property, malleability. Malleability. The racks, RACKS, they are made of iron almirahs because iron can be beaten into sheets. The property of a metal to be beaten into sheets. It is called as the malleability. What is it called as the malleability? Every metal can be beaten into sheet, but which is more malleable? If the concept comes to you, do you remember in your grade the Rutherford alpha scattering experiment. In his experiment, Sir Rutherford used a gold foil that is of 1000 atoms thick. Why did he use only gold foil? Because gold is the one that can be beaten into sheets of very thin size. Even the gold and silver can be beaten into thin sheets. So the malleability is the property of a metal to be beaten into thin sheets. Example, I had used here silver and gold. Even iron is also beaten into sheet, but better than iron, we can make further thin the gold and silver. At your home, your parents or your sisters or yourself will be wearing some gold ornaments. Here, these gold ornaments, once we see, at times they may have a thread type oval in shape. Here, we can observe the same thing again in the electrical wires that are made up of copper. In our home, the electrical wires are made up of copper. For the supply of electricity to the houses also, the main wires are made up of aluminum. But these electrical carrying wires, copper or aluminum, they are not of a direct thick wire. They are woven by more thin wires. How do we get that thin metal wire? What is its property called? The property of a metal to be drawn into thin wire. The property of a metal to be drawn into thin wire. We call as the ductility. We call this one as the ductility. What is ductility? The property of a metal to be drawn into thin wire is called ductility. If you take 1 gram of gold, 1 gram of gold, you can draw it into a very thin wire that can extend up to 2 kilometers length. That can extend up to 2 kilometers length. See, that much ductility the gold is having. And let us see the one more physical property. That is called conductivity. What is that called as the conductivity? Generally, nowadays we use in and around us plastic. But keep in point of view, the electrical wires are carrying the current dimension. They are coated with plastic. Why are they coated with plastic? Inside the electrical wire, the copper wire will be conducting electricity. But outside of the electrical wire, the plastic will not conduct electricity. So once we hold that plastic wire, we will not be passed with the electric current. Means it is plastic is acting as a non-conductor of electricity. But what is this plastic made of? Plastic is also made of carbon. It is made of carbon. One simplest example I want to give for you. You will be using carry bags to carry the vegetables or anything from the market to your home. Nowadays, everyone are suggesting not to use the polythene bags. What? Not to use polythene bags. What is this polythene? First of all, when there are two carbon atoms having a double bond with them, it is called as the ethene. Many of these ethene molecules, when they are held in a side by side, it is called as the polythene. Here also made up of carbon, we are concluding. It is an insulator. It is an insulator. These plastic items are insulators. Whereas this carbon, that is the major constituent in the plastic, it is an non-metal. It is an non-metal. So what we are going to say is that non-metals does not conduct electricity. Non-metals does not conduct electricity, or they does not conduct any heat through them. They does not pass any heat through them. Now our concept is metals are good conductors of heat and electricity. Metals are good conductors of heat and electricity. For that we got a definition. What is meant by the word conductivity? It is the property of a metal to conduct electricity or heat. So let us see one of the activity that metals conducts heat through them. Metals conducts heat through them. Let us see here, children, an activity to study that the metals are conductors of heat. Metals are conductors of heat. For this, we are having some apparatus with us. Let us see what are the apparatus we are having here. We need one metal wire to test whether it conducts the heat or not. Okay, this metal wire, in order to hold it, we are having one stand. We are having one stand. This is the stand, and it is fixed with a clamp. It is fixed with a clamp. The purpose of the clamp is to hold the metal wire. To hold the metal wire. So the clamp fixed to the stand is used to hold the metal wire. So this is the metal rod or the metal wire. This metal wire, at its free end, one of the end is held by the clamp. Another free end is fixed with a nail by the help of the wax. We place some wax on the metal and we place a pin on the wax. So the point of view is, whenever we start heating this metal rod by the help of a spirit lamp or using a Bunsen burner, when we go on heating the metal rod or wire with a spirit lamp or Bunsen burner, the heat that we produce here will be passed along the metal wire. Heat that we produce here will be passed along the metal wire. So now, when the heat is being passed to one of the end, what is there? We have the wax. What happens for the wax when it is heated? The wax will melt. The wax will melt. When the wax melts up, it will fall down along with the pin. Means the pin will fall down because the wax was melted. What are we going to observe here means, the given heat is melting the wax, and once the wax was melted, the pin is falling down on the floor. Is the metal rod melting or wax is melting? Metal also made of with the fats of animals or plants. It is a form of carbon. Carbon is a non-metal. It cannot conduct the heat, but they melt at a very low temperature. They melt at a very low temperature. You have your ballpoint pen with you. Maybe if it is placed with or made with plastic, you heat it near the flame. Does that will melt immediately? Yes, immediately that will shake out because it started melting. When we go on heating, this wax is getting melted. Or now in our present view, the pen is getting melted, that is made of plastic. But the metal, wire or rod does not melt. Instead of melting, what is happening? It is able to conduct the heat through it. It is able to conduct the heat through it. So what is our conclusion means? Metals are having high melting point. Hence they does not melt easily. And also they are good conductors of heat. They are good conductors of heat. So for the conduction of electricity, we are using the copper or aluminum. In our home electrical wiring we use copper, but in the main wires they use the aluminum because they are good conductors of electricity. Here we discussed about heat. Now the same activity we are taking in this form of words. Take an aluminum or copper wire attached to a stand. Take an aluminum or copper wire attached to a stand. Fix a pin to the free end of the metal using wax. Here we had the wax. Here we had the pin. Heat the metal wire near the clamp. Near the clamp, we go on heating the metal wire. Note your observation. What you observed? Wax was melted. Metal was not melted, but instead fell down because it is conducting the heat. At our home, nowadays we are having non-stick cooking pans. What are we having? Non-stick cooking pans. But in the earlier days, the cooking vessels are made of aluminum and copper. What are they made of? Aluminum and copper. You see, when you go on having your noodles near the noodles preparation, they use a big kadai. The big kadai that they use, it is made of aluminum because it is a good conductor of heat. It is a good conductor of heat. So we have discussed that the metals are good conductors of heat.